So today what we're going to do is we are going to work on solving word problems and writing equations from stories. So this is going to be how to write equations from stories. And this is going to be the 12th. And this corresponds with worksheet, I believe it's number 137. So 137's up there. Okay. Get that a little bit better focused. So basically, I'm going to tell you a little bit of a story about grocery shopping, and we're going to write down the important information. So right now it's fall. Everybody loves like a candied apple or apple cider, maybe even an apple pie or an apple crisp. So apples are something that lots of people are grocery shopping for. There's two grocery stores that people shop at. One of them is being Lucky's. I feel like that's not its actual name. It might just be Lucky, but my family calls it Lucky's. So just saying. Okay, and Lucky's is selling their apples for $3 a pound. For $3 a pound. Then the other place that a lot of people shop is Costco. Now, Costco is different than Lucky's because in order to shop at Costco, you have to have a membership, meaning you have to be a part of the organization. And in order to get your membership, you have to pay this one-time flat fee. So the flat fee for Costco is $20. It's really more, but we're going to say it's $20. So we have a $20 membership. And then after I pay this membership and I can go inside and do my shopping, it turns out that they're selling their apples for $1 a pound. For $1 a pound. So this right here is the information that is related to math. So the question would be like, which one is the better deal? Or maybe at what point is one of the stores cheaper than the other? Those types of questions. If I bought so many apples, at what point is it going to be the same cost? So it's going to cost me the same regardless of how many apples or at this price point, sort of thing. So first thing I need to do here is I need to identify my variables. So if you remember back to course 3, we went ahead and we used the 5D process. We also did that in course 2 and course 1. So the 5Ds first would be to draw, then define. So in this situation, I'm going to have let X equal the number of pounds. And the reason X needs to be the number of pounds is because it's the independent variable. Like this doesn't change based on anything. Y is going to be my total cost or dependent variable because the cost depends on how much I purchase. So it changes based on the independent. Over here, I'm going to have X. So let X equal number of pounds. And then I'm going to have Y set equal to total cost. So we normally start with a define, a draw. My drawing is normally math notes, which is what I wrote up here. And then there's like a do math, a declare, all of that other stuff. So now what we're going to do is we're going to take this information and we are going to put it into a table. I have to make a table for this because I'm going to need to plug in different values in order to come up with points to put on my graph. So we should have an input-output table for each of these. I like to make my input-output table have 3 sections. One for the input, one for the output, and then one is going to be where like the math happens. And then we're also going to need to come up with an equation for each one of these situations. Okay, so I have my input-output tables here. Now, in this situation here for Lucky's, Lucky's is $3 per pound. So because it's per pound, we can identify that as the rate. So the equation that would need to be written here is y equals 3x. This right here is my equation. So then on my table, these are my x values. 3x is the math that needs to happen, and y is my output, the total cost. So I need to just go ahead and come up with a couple numbers here in order to have some numbers to graph. So from here, what I'm going to do is I'm going to say, if I buy 0 pounds, how much is that going to cost me? So I have 3 times 0. Well, it should cost me 0 because I didn't actually purchase anything. If I buy 1 pound, I have 3 times 1, and that's going to give me 3. If I have 2 pounds, I have 3 times 2. That's giving me 6. If I have 3 pounds, I have 3 times 3. That's giving me 9. Okay, something that's going to look like that. Then what we're going to do is we're going to come up with some values for Costco. But before I do that, I need to go ahead and write my linear equation. So my linear equation here is going to be y equals, because the total cost is equal to the rate, which is 1 per pound. So that's x, plus the fee, which is my constant, my one-time fee, which is $20. So then I have my input-output table x, and then over here I have x plus 20, and over here I have y. So let's go ahead and take a look at this. If I buy 0 apples, this ends up being 0 plus 20 because I still paid the membership whether I bought the apples or not. Then my next point, let's say I have 2 pounds. So I have 2 pounds plus the membership. This is $22. Then I have, I don't know, 4 pounds. This is 4 plus the membership, $24. 6 pounds. What?
I just had a question. Since you went, since the increments you went for Lucky's was by 1, and the increments you went by for Costco is 2, will that make a difference in our answer?
No.
Okay, so I just wasn't sure if that was supposed to be a thing, or just does it not matter?
It doesn't matter.
Okay.
If we want to fill in the gaps, here's 1 and 3. So this would be 1 plus 20 makes 21. And this would be 3 plus 20, which makes 23. Okay, and we could even put a 4 over here. So this is 3 times 4, which makes 12. Something like that. Okay. So there you have it. These are the numbers for Lucky's and Costco. Now what we're going to do is we are going to go and we are going to graph these equations on a graph. So this is where your graph paper is going to come in. I'm going to move this out of my way. Graph paper. Okay. Now, things to consider here. This graph is going to be the independent variable of number of pounds, and the dependent variable is total cost. It does not make any sense to have a negative number of pounds or a negative total cost. Therefore, this is going to be a one quadrant graph. Does everyone understand that? There's no point to having 4 quadrants on this graph because you're not graphing in the other quadrants. So that's the first thing to consider. Okay, here's the next. We are going to draw this graph. So I need a y-axis. I don't have a long enough straight edge, but I will survive. Okay, the y-axis, and then an x-axis. I'm going to get out a bigger straight edge. Helps if I can even draw a straight line with my straight edge. Okay, sorry for making you seasick. There we go. Now, the next thing is that when graphing, I have to always remember Salton. So I'm going to put a little note here of Salton, which is going to be scale, units. What is L? Labels. T.
Title.
Title. A is accuracy. N is neatness. Okay, so that should be a review. Salton. Every time we graph, Salton needs to happen. So let's just start with, I'm just going to say scale, so we go in order here. I'm going to go ahead and skip count by 2s for my scale. So that way if I count by 1s, it's going to be too hard since my one graph has higher numbers. So 0, due to the fact that this is the origin, then I'm going to have 2, 4, 6, 8, 10, 12. Then going up, this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, something like that. Units. So down here, this is also going to be labels. So this is going to be the number of pounds. And then this is going to be total cost in dollars. So that is going to be my units and my labels. And then my title, this is going to be cost of apples. Cost of apples. And then the only other things I have are accuracy and neatness, which should be happening no matter what anyways. Okay. I'm going to go back to my table and I'm going to take a look at it. And when I do so, my first point to plot is 0 pounds, 0 dollars spent. If I have 2 pounds, I have $6 spent. If I had 4 pounds, I have $12 spent. This is my first line here, which is representing Lucky's. And then if you want, I'm going to just plot a couple other points to make sure my line's really clear, even though I didn't calculate it on my table. So 1, 2, 3 over. So 1, 2, 3 over. 1, 2, 3 over. I'm just going to make some quick scale, some quick slope there. I'm going to make sure that all my points are lying on this line. I'm going to draw my line extending past the point. Arrow on the end due to the fact that it's going to continue on. Okay, other important things. I need to determine if this, well, I should have determined prior to graphing, is this going to be discrete or continuous? This is going to be continuous. I drew a line through it because the number of pounds, you can't pick out perfect apples. Does everyone understand that? Like if I go to the store, I can't like pick the apple up in my hand and think to myself, ooh, this is exactly 0.72 pounds, right? Like, I don't know. I just buy my apples and then I put it on the scale. So you can have the in-between of these numbers that are part of the solution. That's why it's continuous. Then I'm going to look at my Costco membership. So Costco starts up here at 0,20 because I have that flat fee. And then I have 222. I had 424. I had 626. And then if we look here, I'm up and over. So up 1 over 1, up 1 over 1. And now I can draw my line. So I've now drawn my second line. Again, I want to point out to you that it is straight. There is an arrow on the end because it extends for forever. It is also continuous due to the fact that I am not going to buy perfect pounds. I'm going to have fractional parts of a pound. Now, we've done all the graphing and everything, so we need to determine what this graph is telling us and how to interpret the information. So at what number of pounds does it not make a difference as to which store I shop at? How many pounds of apples do I need to purchase in order for it not to matter?
8.
30. 10 pounds.
10.
Oh, sorry, 10 pounds.
10 pounds. Okay, because no matter what store I'm shopping at, 10 pounds is costing me $30. Is everyone in agreement to that? Everyone's okay with that? Okay. Then here's my next question. At which store, if I'm purchasing under 10 pounds, which store is the better buy? Meaning if I buy less than 10 pounds of apples, where should I shop at?
Lucky's.
Lucky's.
Lucky's, okay. And who can tell me why I should shop at Lucky's then? Go ahead, AB.
Because it costs less.
Well, how do you know that?
In the graph, the numbers are the Y value is lower than the Y value for Costco at this point between 10 and 0.
Okay. Okay. So if you look at this down here, if I'm buying anything under 10, these have lower Y values, which would be lower total cost. So that's the better purchase for me. If I'm buying over 10, then which one is the better cost?
Costco.
Costco, right? Because then my Y value is only 32 here or 31 or whatever versus 34 or 36. So once we get past the mark of 10 pounds, that's when the price point changes again. So that is writing an equation from a story and graphing it. Now we're going to do one more example together.
Miss Shaw.
Yes.
For stories like this, will we have like the one sentence answer, or is the graph our answer?
It depends.
Okay. It just depends on the instructions then.
Yeah, it just depends on the instructions. Okay. Now that we've talked about apples, I would like to pretend that I was like making an apple tart or strudel. Apple crumble is actually what we've been making a lot of. I'm going to need to wash it down with a coffee. Just putting that out there, right? Because y'all know how much I love my coffee. So, I am going to go to get coffee at Pete's. And lucky for me, I had a very nice student who gave me a gift card to Pete's for $20. And because I was feeling so generous, I decided that I would probably treat my husband to a coffee as well. Partially because he likes different coffee than me, so it's cheaper. So Brian likes to order a black coffee. And those sell at Pete's for $2 each. Black coffee means that there's no sugar or cream, with like no sugar or milk. It's like straight coffee, which in my personal opinion does not taste good. I, on the other hand, am going to be ordering a latte, Avi, because that's what I drink every day. And unfortunately, that is going to run me $4 a latte. Now, we have, my 2 children that live here with us, so we don't get a lot of sleep. So we have to figure out how much coffee we can actually purchase on this gift card, because we're going to need a lot of it. Like one latte is probably not going to do the trick. So the first thing is we need to start by identifying our variables. So let X equal, let's just go ahead and do black coffee. So number of black coffees. And then let Y equal the number of lattes. Questions so far? Everyone okay with this? I mean, this just sounds like me telling you about a normal weekend, so I feel like you're probably following along. Not even a smirk. You guys are a tough crowd. Okay. So with that being said, I need to go ahead and I need to write a formula for this. And in order to do that, I have to realize that this is not a y equals mx plus b situation. Because in order to be a y equals mx plus b situation, I would have to have something that's going to equal a total cost. But my total cost is a given. So instead, this is going to be written in standard form. That's my ax plus by equals c. Okay. So my ax. So my x is number of black coffees. So I have to determine what the rate is for black coffees. And that's $2. So that gives me 2x. Plus my rate of y. Well, y is my lattes, and lattes are $4 each. So that's 4y. And all of that is going to be set equal to the total amount I can spend, right? I have a budget because I only have one gift card with me. So that's $20. And that is my equation. Now, some of you are going to want to take this equation and you are really, really, really going to want to write it as slope-intercept form. So let's say we did that. Let's say we take this and we write it as slope-intercept form. Oops, sorry, I'm getting a little crazy here. So that would be 2x plus 4y equals 20. I'm going to subtract 2x from both sides. I have 4y equals negative 2x plus 20. Divide by 4, divide by 4. Y equals negative 1/2 x plus 5. Now, this makes it a little bit hard to follow, right? Because like, what does the 5 represent in the context of my problem? Do we even know? Am I purchasing at a half of a black coffee? A rate of a half of a black, like if I go into Pete's and I'm like, oh, I'll just take a half of a cup, don't fill it all the way. And I'm going to ask you to charge me less. Like, does that make sense? And to have a negative?
No.
No. So because of that, if we're trying to figure out for the context of the problem, this makes it a little bit hard and challenging, right? But it does provide us with some good information. What is the good information that this provides me with?
The slope of the line and the y-intercept.
Okay, so the slope of the line. The slope of the line is negative. That's the information it's providing me with to keep in the back of my mind. Now, because again, I need to have a better understanding in terms of context to this problem, I'm going to find the intercepts. So let's go ahead and find the x-intercept here. So I have 2x plus 4 times 0 equals 20. 2x equals 20. Divide, x equals 10. So this is 10, 0. In the context of the problem, what is this representing? You have to look back to what is my x and what is my y.
It means that if you don't buy any black coffees, if you don't buy any lattes, you can afford 10 black coffees with your gift card.
Okay. I don't want to buy my husband 10 black coffees though. Because like, I'm just saying, I want coffee too. So that's not something I want to do. So then we need to figure out what the other intercept is going to be. Of course, I've run out of room. So I'm coming up over here. This is going to be 2x plus 4y equals 20. This is going to be 2 times 0 plus 4y equals 20. This is 4y equals 20. Divide by 4, divide by 4, y equals 5, 0, 5. So now what is this representing?
If you don't buy your
How many
husband any black coffees, you can buy 5 lattes for yourself.
Okay. So I want to point out to you why Starbucks and Pete are so much money, because people are not going there to buy black coffees. So look, I can get half the amount of things because I purchased a latte, right? 10 black coffees or 5 lattes, like you're getting way less if you're buying the lattes. That's a money management life lesson for you, okay? Don't start drinking Starbucks every day. It's bad for your wallet. Things to consider. So now we have all this great information. We're going to go ahead and graph with it. So get out your graph. We need a new graph now, though. Like we can't use the same graph because this is a different problem. So get out your straight edge and your graph. Okay, when we look at this idea of Salton again, I need scale. So in order to think about the scale, I'm going to think back to my intercepts. my X and Y intercepts, which were 5 and 10, right? So I know that this is not going to be a giant graph, so I'm just going to scale it by ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is Pete's. Other important things. My X in this problem represented my black coffees. So I need to have black coffees on my X axis. So this is number of black coffees. And then my Y axis in this problem were my lattes. So I need to label that number of lattes. Okay, so my graph is all set up and I'm ready to go. Now, I want to point out to you that I've converted this to slope-intercept form, and I also have it as standard form, so therefore I have the intercepts. So now I need to decide which one I'm going to use to graph. Let's just pretend I'm going to graph with slope-intercept form. Okay, let's pretend. So if I did that, I would plot this at 5, because that's my y-intercept, and then I have a negative slope of 1/2. So down 1/2, down 1/2, down 1/2, down 1/2, down 1/2. Okay, that looks awesome, right? And then obviously I'm going to connect this line, right? So I'm going to connect it. And then should this have arrows on it?
No.
Okay. Should I have connected this? You guys all just follow along with me as I lead you off the cliff. You have to think.
No, you shouldn't have, because it's not continuous.
Correct. This is not a continuous graph. So everyone that's letting me lead you off the cliff, you have to think for yourself, you guys. Think about this. Can I buy a portion of a black coffee? No, they're not giving me a portion of a black coffee. That's not a good sales management strategy for them. So you have to use your brain. This is discrete. This line does not exist. That's why I drew mine really not dark, because I knew what I was doing with my lesson here. Okay, that's discrete. I can only purchase certain combinations. So if I had 1 cup of coffee here, 1 black cup of coffee, how many lattes can I buy? Well, if I go up here and I look where the line's going, it's a weird number. Do you guys see that there? It's like floating up in outer space here. That's not something that could actually be purchased, because I'm not buying 4.5 lattes. They're not making me a half of a latte. So the only combos that could be purchased are the combos that are represented here with these points on this graph, meaning I get no black coffees, I'm buying myself 5 lattes. That's probably what's actually happening. I buy my husband 2 black coffees, I can get 4 lattes. I buy my husband 4 black coffees, I can get 3 lattes. 6 black coffees, I can get 2 lattes. 8 black coffees, I can get 1 latte. 10 black coffees, I'm not getting anything. These in-between points don't actually exist in the context of this problem. And so we have to think before we graph in order to determine and make sure what we're graphing represents the context of the problem, represents the story, and we can interpret what the graph is telling us. So that is the information we need in order to write our equations from a story and then to graph them.